How can we assess the uncertainty in the final result? Okay. To assess the total uncertainty or error, it is necessary to evaluate the likely uncertainties in all the factors involved in that calculation. The maximum possible uncertainty or error in the final result can be found as follows. For addition and subtraction, absolute uncertainties are added. For example, the distance x determined by the difference between two separate position measurements x1 is equal to 10.5 plus minus 0.1 centimeter and x2 is equal to 26.8 plus minus 0.1 centimeter is recorded as x is equal to x2 minus x1 is equal to 16.3 plus minus 0.2 centimeter. For multiplication and division, the percentage uncertainties are added. For power factors, multiply the percentage in uncertainty by that factor. For example, in the calculation of volume of a sphere, V is equal to 4 over 3 pi r cube. Percentage error in volume is equal to 3 multiply percentage uncertainty in radius r. For uncertainty in the average value of many measurements, find the average value of measured value, find deviation of each measured value from the average value. The mean deviation is the uncertainty in the average value. For example, the 6 reading of micrometer screw gauge to measure the diameter of a wire in millimeter are 1.20, 1.22, 1.23, 1.19, 1.22 and 1.21. Add all these quantities and divide it by 6 and we obtain average value is equal to 1.21 millimeter. The deviation of reading, which are the difference without regards to the sign between each reading and average value, are 0.01, 0.01, 0.02, 0.02, 0.01 and 0. Mean deviation of these are found as adding all these 6 quantities and divided the sum by 6. Average mean of deviation is equal to 0.01 millimeter. Thus likely uncertainty in the main diameter 1.21 millimeter is 0.01 millimeter, recorded as 1.21 plus minus 0.01 millimeter. For uncertainty in the timing experiment, the uncertainty in the time period of a vibrating body is found by dividing the least count of timing device by the number of vibrations. For example, the time of 30 vibration of a simple pendulum recorded by stopwatch accurate up to 1/10 of a second is 54.6 second. The period t is equal to 54.6 second over 30 is equal to 1.82 second, with uncertainty 0.1 second over 30 is equal to 0.003 second. Thus time period t is quoted as t is equal to 1.82 plus minus 0.003 second. Hence it is advisable to count large number of swings to reduce timing uncertainty. Okay, thanks.